Hello, my name is Ricardo Dominguez, and I was a developer on the collaborative platform application during the fall semester of 2015. My mentor is Juan Caraballo, and my instructor was Dr. Masood Sajadi. So let's get into it. The main problem nowadays is that there really is no one-to-one interaction between students and professionals. Let's say that a student has a problem in a class somewhere, and he needs an answer to a very specific question only provided in that class. What the student must do is he must rely on several sources throughout the internet. He has to Google certain things, and a lot of the time, the answers that he gets might not be the ones he's looking for, but rather similar. There are other times that the students ask questions, and a lot of the times when the student asks the questions, even on the correct websites, it can take days or even weeks for the questions to be answered. On the flip side, professionals looking to mentor and help students in fields that have to do with their line of work find it increasingly difficult to find some kind of medium where they may reach the students. So this is where our system comes in. This is where Collaborative Platform shines. Collaborative Platform is a system that facilitates communication between mentor and mentee, the mentors being the professionals, the mentee being the students. It does it through ticket creation and management. What a student will do is that if they have a question, they will register to our website using our very easy to use register feature, and they will then be allowed to ask a question. This question will be given to a mentor that specializes in the field. The mentor then has a window of time to reply. If the mentor does not reply, the question is given to another mentor. A mentor that knows the answer to this question might also request some kind of meeting with a student. Our website allows student and mentor interaction to be done face-to-face, even replacing current programs like Skype. Once a student is knowledgeable enough, if he or she chooses, they may apply to be a mentor, whether it is a domain mentor, or a project mentor, or even a personal mentor to another student that is having difficulty with a certain subject. This process is managed by the system administrator. Once the process is complete, a mentee can become a mentor and help other students who were once in their position. The current system also has a report system for the administrator to use that reports mentor and mentee activity. This makes it easier for us to know exactly how many mentees there are, what their questions are on, how many mentors there are, and how many questions they've answered. The main problem encountered in the fall semester with this iteration of Collaborative Platform was that the mentor and the mentee had really no way of providing the administrator with some kind of feedback. Perhaps there was something that the system could do better, something that would be easier on the user. The solution for that was to give users the ability to give feedback to the administrators. This allows for a more open communication between the users of the application and the administrators of the application. Another problem with the current iteration of the system was code coverage. There were little to no tests done for a lot of the features and subsystems provided, whether they be functional or unit tests. The solution to this was to create a series of suites that provide as code coverage for our system in case of a future update or some kind of code refactoring. This will ensure that whatever changes are made to the system are able to be tested to ensure that the system is running as intended in correspondence to the use cases that were provided through previous documentation. The last problem that was encountered with the current system was that it was very limited to the current framework, which is the E framework. If the system needs to be expanded to another framework, there really is no way to do it other than to take the code as it is and rewrite it for the other framework. The solution for this is that using the tests provided, programmers can actually add and take away from the system while ensuring that functionality is still prevalent. This provides an extra resource for developers in the future to use, along with the documentation that has been provided, so that they may add or take away from Collaborative Platform as a whole. The implemented user stories for feedback were very straightforward. There was a create that allowed users to create feedback that the administrator could view. There was a delete, only accessible by the administrators, that would allow them to delete posted feedback. There was a reply, which is a dialogue between the administrator and the author of the feedback that allows them to exchange messages through that forum. There is also add to feedback, which allows the original creators to append comments to the feedback that they created. There is manage feedback, which allows the administrators to manage any posted feedback, whether it be to delete or to reply. And finally, there is view feedback, which lets users view other user feedbacks without actually allowing them to impact the feedback in any way, meaning users cannot reply to feedback they did not create. The class diagram shows the interaction between the subsystem and the user. The user sees the views created by the controller, enters the information into the fields where the controller calls the models, and depending on which view the user is currently on, it accesses different fields of the database through the model into the controller and compiled into a view. The sequence diagram for creating feedbacks is very straightforward. The user navigates to the feedback view. The system checks whether the user is an admin or not. The system then determines whether it is a user or an administrator. The user then clicks create feedback. The action is fired, and the system gets the current user that is logged into the system and returns it to the controller, which returns it to the view. The user enters the feedback information and then clicks submit. The feedback is posted into the controller feeds it to the model feeds it to the database. Delete feedback works in a similar fashion, where the user navigates to the view. The system checks whether the user is an admin or not. If the user is an admin, they can click the delete feedback button. The system then gives them a confirmation prompt. Upon accepting it, the view tells the controller tells the model deletes it from the database, which then sends a success signal to the model, which sends it to the controller and shows it back to the view in the form of a modal dialog. Reply to feedback works when the user navigates to the view. The system determines whether it's an admin or the user that created the feedback. The user clicks reply to feedback. The action is then fired. It gets the current user ID. It navigates back to the view. The user enters the reply, clicks submit, and then the interaction between view to controller, to model, to database. The database communicates with the model, which communicates with the feedback reply controller, which communicates with the feedback reply view, and then tells the user, using the view, that the reply has been submitted. The last sequence diagram explains how to update feedback. The user would log in. The system determines that they are the user that created the feedback. They click on update feedback. The create action is then fired. The system gets the current user ID. It renders the form to update the feedback. The user enters the update, clicks submit. The update is then posted to the controller, which communicates with the feedback model, which inserts the information into the database. The database then prompts the model, which prompts the controller, and then informs the user that their feedback has been updated. An important facet of this iteration of collaborative platform was the unit testing. The unit testing was done using PHP Unit 5.1. The unit tests cover the current system, as well as the newly implemented feedback subsystem. The benefits offered by unit testing are that it allows the developer to update the current system with ease. It shows us current weaknesses within our code or areas that require refactoring. It helps us improve our code by making it testable. What this means is that if a current piece of code is not testable, meaning that there is no way to write a unit test for it, it allows us to see that there is a problem with the code and must then be refactored. It also helps the developers, both present and future, to better understand the code and how the intended system is supposed to run. Finally, functionality testing was done with Selenium IDE, the non-licensed version. There are a few key differences between the non-licensed version and the licensed version, but for what we wanted to accomplish this semester, the non-licensed version proved to be a very valuable asset. Functionality testing tests the current system's front end to ensure that all subsystems are working as intended to the users. The benefits of using Selenium IDE is that it allows for easy code updating by making sure that any code added or taken away will not affect the system, and the system will work as it is intended to. It is easy to update. Selenium IDE has become a current standard because of its user-friendliness and the wide variety of coverage that it provides. It simulates user interaction and ensures that different user stories are working as intended. This concludes the introductory video to the collaborative platform system. Thank you for watching.